Today we're going to be talking about solving radical equations again, but today we're going to add in the idea of extraneous solutions, and that just means that when you get a solution and you plug it back in, if it doesn't work, if it makes the original equation untrue, then it is an extraneous solution and we have to cross it out. So if we have the square root of x minus 3 plus 5 equals x, we have to work on solving this. Just like we did prior to this, we are going to isolate the radical, get that by itself. So that means we're going to have to subtract 5 on both sides. So we have the square root of x minus 3 equals x minus 5. Those two things aren't like terms for us to combine, but we do need to work on getting the radical, getting rid of the radical. So we're going to square both sides just like we did yesterday, and we would get x minus 3 equals x squared minus 10x plus 25. So remember, when you square it, you've got to write it twice and distribute. Alright, so then we're going to move everything to one side since we have x squareds and x's. So I have my x squared. I'm going to move everything over to the right to have a positive x squared. So that means we would have minus 11x and plus 28. Now that it's a quadratic, you have your options of how to solve. One of them being factoring, which is what I'm going to go with. In order to get x squared, we need x and x. We need the back two spaces to give us 28, and we need them to add together to give us negative 11. So that would be x minus 7 and x minus 4. Once we have it factored, we set each one equal to 0 and solve. So we get x equals 7 and x equals 4. And then we have to test those. So we plug in 7 back to the original equation, all the way back here. 7 minus 3 is 4. The square root of 4 is 2. 2 plus 5 does equal 7, because 7 is the x value that we plugged in here, so that works. If we plug in 4, 4 minus 3 is 1. The square root of 1 is 1. 1 plus 5 is 6. Well, we plugged in 4, not 6. So that one's not an answer. That is an extraneous solution, and we cross it off. So what happens if we have the square root of x plus 2 minus 3 equals 2x? Okay, isolate the radicals, so we're going to add 3 to both sides. The square root of x plus 2 equals 2x plus 3. To get rid of the radical, we're going to square. That means we have x plus 2 equals, multiplying this by itself, we would have 4x squared plus 12x plus 9. And then we're going to move everything over to the right to be with the positive x squared. So we get 4x squared, moving the x over, we would have plus 11x, and moving the 2 over, we have plus 7. So when we factor this, we have to figure out, do we want 2x and 2x, or 4x and 4x? In order to make all this happen, we do need 4x and x. The only way to get 7 is 7 and 1. So I want the 7 to be with the 4 so that I'm not multiplying them together. And when we set this equal, set them both equal to 0 and solve them, so we would subtract 7 and divide by 4, so negative 7/4. And over here we would subtract 1, so x equals negative 1. Alright, so when you're plugging these back in, let's plug the fraction in first. And let's do a little work off to the side. So we would have negative 7/4 plus 2, but I got to make that be into fourths, so that would be 8/4. We want to know if this is equal. Okay, so this would give us 1/4. The square root of 1/4 is 1/2. 1/2 minus 3 would give us negative 2.5. Over here, we would take 2 times negative 7/4, and we would get negative 7/2, which is negative 3.5. Since those two things aren't equal, x equals negative 1 is, x equals negative 7/4 is the one we were testing there. That doesn't work. Negative 1, if we plug that in, negative 1 plus 2 is 1. The square root of 1 is 1. 1 minus 3, that makes this side be negative 2. If we plug in the negative 1 for x there, we do get that to work. So ignore the fact that I crossed it off before. So negative 1 is our solution. All right, let's look at 2x plus 1 to the 1/2 power minus the quantity 3x plus 4 to the 1/4 power equals 0. So here we have two sets of parentheses, two sets of radicals is ultimately what this is. So we do need to isolate them and separate them from each other. So we would add this one over to get 2x plus 1 to the 1/2 equals 3x plus 4 to the 1/4. Now, our job, just like we did previously when we had these, is to multiply by the reciprocal. So if I take both sides and square it, because that's the reciprocal of this, 1/2 times 2, those would go away. If I take this side to the second power, I would be taking 1/4 times 2. That's going to give us a half, and that's not eliminating the fraction. So what we want to do is multiply. If we look at multiplying by 4, okay, so if we take both sides to the 4th power, then we would have 2x plus 1 squared being equal to, these will now cross off, and we get 3x plus 4. Okay, so 2x plus 1 squared gives us 4x squared plus 4x plus 1. And then moving, now we're going to move over to the left because that's where we have our positive x squared. So subtracting the 3 x's, we would get x. Subtracting the 4, we would get negative 3. And when we factor this, we're going to factor into 4x minus 3 and x plus 1. Set them equal to 0 and solve. So here we get x equals 3/4 and x equals negative 1. So you don't have to show your steps of like what you're doing, setting it equal to 0 and things of that nature, but we do need to test these. Okay. All right, so if we test, again, I think it's easiest with fractions if you're like showing some steps of it. So we're taking 2 times 3/4, so that would give us 3/2 plus 1 would be 2/2, and that's all to the 1/2 power. And then we have 3 times 3/4, so that would be 9/4. Plus 16/4, all to the 1/4 power. And we got to make sure that that equals 0. So here we would have 5/2 to the 1/2. And then here we would have 25/4 to the 1/4 power. Now what do you notice between these two things though? The 4th power is just taking the square root of a square root. So if I make this be 2, like if I take the square root of this, we would have 5/2 to the 1/2 minus 5/2 to the 1/2 power because we've taken the square root there. And so these two things are the same, which means this is an answer. Okay. If you plug negative 1 in, 2 times negative 1 is negative 2 plus 1 is negative 1 to the 1/2 power. So we've got that going on. 3 times negative 1 is negative 1. Negative 3 plus 4 is 1. and that's to the 1/4 power. So then when you subtract those two things, that would not equal the same thing because we can't take the square root of the negative number over here. So the x equals -1 is not an answer. Okay? All right, so then let's take a look here. I alluded to this a little bit in the previous day's video, that if we have the cube root of 2x minus 4 equals -2, if we have the cube root of something, the way to eliminate that is to cube both sides. So then 2x minus 4 would equal -8. So we add 4 to both sides. 2x would equal -4. Divide by 2. And x equals -2. If we take that and plug it back in, 2 times -2 is -4. -4 minus 4 is -8. We can take the cube root of -8, and then that is -2. So there's our answer. All right, what happens if we have 2 times the square root of x equals the square root of x plus 6? So here we do need to work on squaring both sides. If we divided by that 2, it wouldn't do anything. It would actually make things probably more complicated by creating a fraction. So with this, we're going to square both sides. When we do that, we have to square the number and square the radical. So we're going to get 4x equals x plus 6. And then we subtract x. So 3x equals 6. Dividing by 3, we get x equals 2. So when you plug this information back in, I'm going to write this one out. So we have 2 radical 2 equals the square root of 2 plus 6. And that may look like it's not going to work, but 2 radical 2 stays there. This would be radical 8. And remember, we can split the square root of 8. We can split that 8 into 4 and 2. The square root of 4 is 2, and the other 2 stays inside. So it actually is a solution, even though it doesn't look like it right away. All right, one last question here. If we have 3 plus the square root of x minus 4, and that equals 2, we're going to isolate the radical, meaning we're going to subtract 3 on both sides. And we get the square root of x minus 4 equals -1. Now we're going to work on getting rid of the radical, so we're going to square both sides, and x minus 4 would equal +1. Adding 4 to both sides, we get that x equals 5. So then when we go to test this, 5 minus 4 is 1. The square root of 1 is 1. 3 plus 1 is not 2. So this doesn't work. Since that's our only answer, and it doesn't work, we would answer no solution for this. Now, obviously, we want to be able to figure this out way earlier here and not do all of this work. If we look back here, we had the square root of x minus 4 equals -1. When you take the square root of a number, it's always should be producing the positive answer. So if you get the square root equal to a negative number in your process, at that point you could stop and just say no solution. You would not have to continue on. If you don't recognize that and you continue on, then that means that you would check it and you would get no solution. And that's it.